this into the right spot. All right. Alondra, can you read us the essential question, please?
How do you use Hopital?
Hopital. Say it again. Hopital.
Hopital.
There you go. All right. Amy, can you read us the ICANN statement?
I can determine limits of functions that result in indeterminate form.
Perfect. Okay. So remember, an indeterminate form is 0 over 0, infinity over infinity. Those were the two we are probably going to see in this class. Okay. Most likely 0 over 0. All right. L'Hopital's rule is how we deal with indeterminate forms and taking their limits. We take the derivative of the numerator and the derivative of the denominator, and we try to delimit again. And we can do that repeated times. That's what we kind of talked about yesterday. On today's, write small, because some of them, the space, I did not give you enough space. So write as tiny as you can. If you really need it and you're on paper notes, I can give you a giant sticky note to put over the top. If you need more space, just let me know. Okay? Happy to do that for you. All right, so we were down and we are working through example 3. There is a little bit missing in the instructions there, so let's add that in really quick and then you can read it kind of to yourself. All right, so the words in front of this selected values should have been is twice differentiable with, and then it should have said table to answer the following. Should have been at this, to answer the following. Apparently I chopped off the ends of my notes. Okay, once you have that, read the instructions to yourself, please. Figure out what we're supposed to be doing. Okay, so we basically, it's kind of our standard instructions that when we have a table and a graph, right? We've got F, it's got 3 line segments. G is twice differentiable, meaning we can take, they've given us 2 derivatives worth of things. And then we're supposed to use that in order to answer the following questions, okay? So they could very easily give us a wide variety of things. Our focus today is on limits and L'Hopital's rule. So we are going to start with example 3 there. I'm going to start, I know I'm probably going to run into zeros, so I'm going to just start by splitting and taking the limit of my numerator and my denominator separately, because that's the proper way to write it. We talked about that yesterday. So we've got the limit as x approaches -2 of f of x minus 1. And we've also got to find the limit as x approaches -2 of 2x plus 4. All right, we're going to go ahead and put in our -2. So f of -2 minus 1. All right, our pictures in our table are marked very clearly marked. Our f is our graph, right? It says that right on there very clearly. I need to go to -2. To find f of -2, is that the slope or the y value? Y value, good. Okay. And what is the y value there? 1. 1 minus 1 is?
0.
Surprise, surprise, we got a 0. Okay. On the AP test, these limits will be mixed in with our limits where this doesn't happen. Okay. So they won't always be 0, 0 when it comes time for May. Okay. All right. Then we've got 2 times -2 plus 4. What's 2 times -2? -4 plus 4 is? All right, so we've proven that we're indeterminate, right? Our numerator and our denominator are both 0. So we need to do L'Hopital's rule. Okay. So I'm going to do my little notation for L'Hopital over here. L'Hopital equals the limit as x approaches -2. Okay. We are going to take the derivative of our numerator and denominator separately. Please be careful because you don't want to mix this up with quotient rule. So when you do a quotient rule, you still have to do the quotient rule. You can't just do derivative top, derivative bottom. Okay, that only is L'Hopital's rule. All right, so what is the derivative of f of x? Good. And what's the derivative of -1? 0. Don't need to write it down, right? What's the derivative of 2x plus 4? Perfect. Good news is I don't have 0 in the denominator anymore, so I'm probably safe to just direct substitute in now. Okay. So I'm going to go f prime of -2 over 2. It's been a while since we've done a graphical stem. When I have f prime, am I looking at the y value or the slope? Slope. Good job. You guys have been well trained. All right. So we'll be ready for these kind of questions on the AP test. All right. What is the what's the slope there? -1/2 divided by 2. I think the worst part of this whole problem is that right there, right? Dealing with the complex fraction. Technically, this is 2 over 1. To get it out of that, we have to flip and multiply by the reciprocal. So my limit on this is -1/4. Okay. It's not horrible. As we go through these, there's another little twist and a little thing here and there that makes it a little bit more complicated, but the concepts are very similar throughout the whole thing. Okay. We're going to review some of our derivative rules and those kind of things as we go through here. Okay. All right. So looking at example 4, again, when I look at something with a fraction, I'm probably going to automatically take my limit of my numerator and denominator separately. In the interest of making sure I have enough space, I'm going to do this out in the left-hand column. I know that's not what we're supposed to use the left-hand column for, but that's what I'm going to do today. All right, g of x, just don't tell the avid teachers, right? So 3e to the 2x minus 8. And then I also need to find the limit as x approaches 4 of 4 minus x. Okay, so I'm going to go ahead and direct substitute in. G of 4 equals 3e. Let's do a little bit in our heads. What's 2 times 4? 8. I forgot a plus sign. So 8. There we go. All right, remember I have to do G of 4 out of the table. Okay, so G of 4 is what? -3. Okay, I'm gonna let you probably read the table the rest of the lesson. Okay, I'm not gonna keep scrolling up and down. All right, so we said it was -3 plus. All right, what is -8 minus 8? 0. What's e to the 0? And 1 times 3 is. I did a lot in my head, right? It's okay for you to do the same amount in your head. All right, if you need the steps, write the steps. All right, -3 plus 3 is. Okay, so we've proven our numerator is 0. Let's try our denominator. So I'm going to go ahead and put my 4 in. 4 minus 4 is 0. So we have indeterminate. Our numerator is 0, our denominator is 0. So now I'm going to apply L'Hopital's rule. Okay, here we go. So the limit as x approaches 4, I'm going to start taking the derivative of the numerator, derivative of the denominator separately. So it's the derivative of g of x. Good. All right. I can keep the 3. What am I going to need for the e? We have to have a chain rule, right? That's why I needed more space. So I'm going to do my chain over here to the right. So u equals 2x minus 8. And if you have figured out a shorter way to do the chain rule, you can do that. Okay? I'm going to keep going the long way till we're well into the next phase of calculus here. Okay? All right, so u prime equals, what's the derivative of 2x? 2. Don't need to worry about the 8. We know that our f is e to the u, and we take the derivative of it. What's the derivative of e to the u? E to the u, and then times the inside, which is 2. And then I'm just going to go ahead and substitute everything back in all at the same time over here on my top line. So trying to work smart and not too hard. I'm going to go 2e, and instead of writing u, I'm going to write 2x minus 8. All right, 4 minus x, what's that derivative? -1, and yay, no 0 in the denominator, so it looks good for direct substitution. So I'm just going to go ahead and I'm going to plug in the 4. At this point, remember, I can drop my limit notation out front. I could not drop it before this. Okay, so g prime of 4 equals, I'm going to go ahead and multiply the 3 and the 2 together. Why did I write equals? No idea. I should have written a plus sign. Plus 6 e, all right, let's see, 2 times 4 you already told me is 8, right? So 8 minus 8 all over -1. All right, go to your table. I'm going to trust your work out of the table. So you guys got to read your own tables today. What's g prime of 4? -1. Okay. And then let's see, e to the 0 power again, because of the 8 minus 8. What's e to the 0? 1. So I just get 6 here. All right, what's -1 plus 6? 5 over -1. Or you could go right to the -5. That's fine. Okay. Either way, it's good. I assume you could do that fraction, all of that in your head. Your AP Calculus second semester, we should be able to do some arithmetic in our heads. All right, we good with example 4? I'm going to give you an extra couple seconds here to make sure you've got it all written, because I know sometimes I go too fast. At least I don't erase it and write it in the same line, right? So there are some professors in college, if they still use the whiteboard, sometimes they write with one hand and erase with the other. You got to write really fast in those classes. So a few years ago, they told me there was still one at UCR. So I don't know if that person's still there or not, but they did tell me there was one that did that. And they didn't believe me. They should have. I had one. I think that my stats professor was like that in college. Therefore, I hate statistics. All right. Statistics got soured because I did not have a good teacher. All right. Let's take a look at 5. We're going to assume we're doing La Hopital, right? I'm going to go ahead and just do my limits separately. So I'm going to put some work out in the left-hand column here. So the limit as x approaches 0, g prime of x minus 6 cosine of 4x. And then we also have the limit as x approaches 0 of f of g of 0. Okay. I want you to try to plug in your 0 and try to figure out those limits on your own. We all know what the answer should be, but see if you can get to that answer on your own. It's been a while since we've done a few of those things. So. Give me about 30 more seconds, and we're going to check it together. Okay, I plugged my 0 into that first one, and I totally messed up on this one, didn't I? That should be an x still, not a 0. Then do f of g of 0. My fault. Okay, g prime of 0, what'd you get from the table? 6. All right, minus, now remember cosine of 0. I have to go back to good old unit circle, right? What is the cosine of 0? 1. So 1 times 6 is 6, so we get 0. Okay, make sure you understand how we got 0. That's the important part here. Okay. All right, you hopefully read out of the table what was g of 0. What was it? 0. Okay, what was then we got to go f of 0, which was the graph. F of 0 is 0. Okay, so make sure you understand the analysis. Okay, so we definitely have indeterminate, which means I need to start taking some derivatives. Maybe some of you even got that far. So doing the Hopital's rule, I want the limit as x approaches 0. What's the derivative of g prime? G double prime. There you go. Okay, remember how they said it was twice differentiable at the beginning? That's why, because we just had we had g prime, we had to take a derivative of it. All right, minus 6. All right, what am I going to need for the next part? I got to do a chain rule, right? So u equals 4x, u prime equals 4. If I was going to be official and write out all my work, I would go cosine of u, right, with my orange in there. What's the derivative of cosine? Just sine? Negative sine of u, and then times the inside, which is 4. And I know I could do that pretty fast now. Okay, because we should be able to do it pretty quick. All right, I'm going to go ahead and rewrite this over here. So it is, I'm going to write it as negative 4 because of the negative in front times the 4. Sine of u, which is the 4x. Okay, and then that's all over. Now, ooh, what do I get to do now for the denominator? Another chain rule. Wasn't that nice? Double chain rule. Okay, so u equals, and again, I could use w. I really probably should. I'm being kind of lazy. All right, what's the derivative of g prime? Or sorry, g. G prime of x. But this is one we could almost have memorized, right? Because we've done it so many times. All right, I'm not going to call it f. I don't know. We'll call it something else. P. P equals f of u. P prime equals f prime of u, and then times what? G prime of x. Okay, and then I'm going to rewrite it nice underneath here. Okay, so we have f prime of, instead of u, we're going to write g of x, and then times g prime of x. Okay, what's my next step? We're going to plug in a 0. We're going to hope that we don't have to do another chain rule on this one, or another Hopital on this one, so let's just plug it in. We'll live dangerously. G double prime of 0. I'm going to multiply together the negative 6 and the negative 4, which is going to be positive 24. Sine 4 times 0 is what? 0, so I've got 0 there. Over f prime of g of 0 times g prime of 0. Okay, so let's start finding the stuff in the table. What is g double prime of 0? 2, good. Plus 24. What's sine of 0?
1.
Careful. There's my thing, right? What's sine of 0? 0. Okay, help me out in the table. What's g of 0? G of 0. It's 0? Okay. Too many zeros. That's right. It's really great. There were problems I did in college, and we do like a page and a half of work, and we get a 0 at the end. Doesn't that make you feel good when you do like this whole page and I get nothing at the end? All right. What's g prime of 0? 6. Good. All right. Looks like I've got just 2 in the numerator. F prime, do I read the y value or the slope? Slope at 0. So slope at 0 is still what? -1/2. Okay. So we have -1/2 times 6, which if you're going to have a fraction in the denominator, that's the situation you want, right? Because I can cancel some stuff. All right, so 2 goes into 6 3 times. It looks like I've got -2/3 as my limit. All right. Again, I don't think it's hard. I think hopefully we have the concept down. It's just sometimes some of the little nuances get tedious. Okay? We had 2 silly chain rules in that one that we had to deal with. All right. The good news is look at example 6. There's no chain rule in it. I wonder what they were thinking. Okay? I want you to try 6 on your own. The hint I'm going to give you is that you're probably going to have to use the Hopital twice. Okay, so that's the twist in that one. At least there's no chain rule, though. Okay. All right, so everybody try 6. See if you can do it. Make sure you prove your numerator and denominator limits are 0. You have to do that. Okay, separately, remember, not together. Okay, no matter yet, let's check out let's check it out together. Okay, so do you agree with my proof of my numerator and denominator equaling 0? Let's check that part out first. I did a little bit of it. We good? Everybody okay and got their zeros proved? All right. Do you agree with my derivative, my top derivative, my bottom? Okay. And really, we should be able to eyeball the fact that denominator is going to be 0 if I plug a -2 into it, right? So that should kind of be a red flag. Oh, I'm seeing that ahead of time, so I better write these down separately. So I'm going to do the limit as x approaches -2 of g prime of x plus 2x, and the limit as x approaches -2 of 2x plus 4. All right, we're going to direct substitute in. So I've got g prime of negative 2 plus, what's 2 times negative 2? Negative 4. Okay, help me out with the table. What's g prime of negative 2? 4. Oh boy, so we got 0 again, right? Oh, okay. I'm going to plug in this denominator 1. We get 2 times negative 2 plus 4. What's 2 times negative 2? Negative 4 plus 4 is. So when we get indeterminate form, what do we have to apply? Well, Hopital's rule. Oh, I didn't even make my little thing here, did I? All right, so here we go. The Hopital's rule. Did I go too fast? We okay? All right. So I'm going to do the Hopital one more time. So limit as x approaches negative 2. What's the derivative of g prime? G double prime. What's the derivative of 2x? 2 over derivative of 2x plus 4. 2. Yay, finally no variable in the denominator, right? That's a good sign. Means this is our last round of this. Okay? I'm going to plug in my negative 2. All right, so help me out with the table work. What was g double prime of negative 2? 3 plus 2 over 2, which is going to give me, that's a 5 halves. Good. All right? So that's it. Woo, yes, yay, exciting. Okay, so you've learned everything we need to learn to be able to take quizzes at the end of this week. Okay? You should be right now. We've got like more than 20 minutes left of class. Open, even if you don't do all of the homework, okay? Open up and practice. You've got 20 minutes of time here in class designated for practice. I think this is the class where I just said to do 6, 7, and 8. I can't remember. One of the classes. Yeah. So look at the homework here on this worksheet. The first half of the worksheet does what we did yesterday with the variables. 6, 7, and 8 practices the tables and the graphs. Okay. So I would start with at least these problems. If you want more practice on the other, there's more there for you. Okay. It's up to you whether you do it or not. All right. Any questions? All right. You guys are, it's up to you to go ahead, spend the last 20 minutes or so practicing. Okay.